What if one of the quietest worlds in our solar system is hiding the loudest secrets? A tiny dwarf planet drifting between Mars and Jupiter may hold clues that could rewrite everything we thought we knew about how worlds, and maybe even life, began. For years, scientists thought of Ceres as nothing more than a quiet leftover from the solar system's earliest days. But when NASA's Dawn spacecraft arrived, it revealed something that stunned the world. Organic molecules scattered across its surface. These weren't just random chemicals, they were the very building blocks of life itself. Suddenly, this small, unassuming dwarf planet wasn't just a frozen relic. It was a potential archive of biology waiting to be decoded. The discovery raised a storm of questions. Were these molecules created on Ceres itself, forged by chemical reactions deep inside its crust? Or were they delivered by comets and asteroids crashing into its surface over billions of years? Each possibility was shocking in its own way. If they formed locally, it would mean Ceres had the right conditions for chemistry that could lead to life. If they came from outside, it would mean Ceres acted like a cosmic storage vault, preserving fragile compounds from the earliest days of the solar system. And the surprises didn't stop there. Alongside the organics, scientists found bright salt deposits glowing like icy scars across Ceres' surface. These patches weren't just pretty, they hinted at something moving beneath the crust. Salty brines, possibly liquid, may have seeped upward through cracks, leaving behind shimmering trails as they evaporated. Imagine that. A world thought to be frozen solid, quietly hiding pockets of liquid beneath its surface. The implications were enormous. If brines still exist today, even in tiny amounts, they could provide the energy and chemistry needed for microbial life. Not the bustling oceans of Earth, but something far quieter. Life surviving in shadows, clinging to saltwater veins deep underground. But molecules and brines were only the beginning. What scientists uncovered next would push the mystery of Ceres even further. If organic molecules weren't enough to raise eyebrows, what scientists uncovered next pushed Ceres into an entirely new category. Beneath its muted surface lies evidence that this quiet dwarf planet may once have been habitable. Not in the way Earth is, with oceans and forests, but in a far subtler, hidden form. Researchers studying data from NASA's Dawn mission found signs that Ceres may have harbored subsurface oceans billions of years ago. Imagine a world wrapped in ice and dust, yet hiding salty liquid beneath its crust. These briny reservoirs weren't vast seas, but interconnected pockets and channels, slowly shifting over geological time. Even today, some of those brines may remain unfrozen, creeping upward through cracks and fractures. The proof came in the form of bright deposits scattered across craters like a crater. These shimmering patches of sodium carbonate salts weren't just surface decoration. They were chemical fingerprints of liquid brine rising from below. When the brine reached the surface, it evaporated, leaving behind dazzling white scars that glowed against the dark terrain. To scientists, these deposits were more than minerals. They were whispers of a hidden ocean that once stirred beneath Ceres' crust. And here's where the story takes a shocking turn. Those brines may have provided the chemical energy needed to sustain microbial life. Not the kind of life we imagine thriving in sunlight, but organisms clinging to saltwater veins in the dark, feeding off chemical reactions between rock and liquid. If true, Ceres would join the ranks of icy worlds like Europa and Enceladus. Small, cold, and yet potentially alive in ways we never expected. But the mystery deepens. Some researchers argue that Ceres' interior may still be active, with faint pockets of liquid brine shifting even now. If that's the case, then Ceres isn't just a fossil of ancient habitability. It could be a living laboratory, quietly preserving the chemistry of life beneath its surface. And if Ceres really did harbor oceans and energy long ago, what else might it be hiding about its origins? Just when scientists thought they understood Ceres, a strange clue appeared in its chemistry. One that suggested this dwarf planet may not even belong where it is today. Deep inside Ceres, researchers found ammonia-rich minerals. At first glance, This might not sound unusual, but here's the twist. Ammonia struggles to survive in warmer regions of the solar system. It's far more stable in the icy, distant zones beyond Jupiter, where temperatures are brutally cold and sunlight barely reaches. So why would a body orbiting between Mars and Jupiter carry the chemical fingerprints of a much colder birthplace? This discovery sparked a bold theory. Ceres may have formed far beyond its current orbit, in the frigid outer reaches of the solar system. Over time, as the young solar system shifted and evolved, Ceres could have migrated inward, carried along by the gravitational tides of gas and dust. Instead of being born in the asteroid belt, it may have traveled there, a visitor disguised as a resident. If true, this changes everything. It means Ceres isn't just a leftover fragment from the asteroid belt. It's a cosmic traveler, a world that journeyed across billions of kilometers, bringing with it chemistry from distant regions. Its ice, salts, and clays may be relics of a colder birthplace, preserved like fossils inside its crust. Picture the early solar system, a swirling disk of gas and dust, planets forming, giants like Jupiter tugging at smaller bodies. In this chaotic dance, Ceres may have drifted inward slowly, not violently thrown, but gently guided by the currents of the protoplanetary disk. By the time the gas cleared and the solar system settled into its long-term layout, Ceres had found its home between Mars and Jupiter, carrying secrets from far beyond. This theory makes Ceres even more mysterious. It's not just a dwarf planet. It's a messenger from the outer solar system, holding chemistry that doesn't match its surroundings. And if migration shaped its destiny, then Ceres may be proof that small worlds can wander across vast distances, rewriting the boundaries of where life's ingredients might be found. But if Ceres really is a traveler, then the question becomes, what forces allowed it to survive the journey when so many other bodies were destroyed or consumed? If Ceres really did migrate inward, then the question becomes, how did it survive in a region dominated by the most powerful planet in the solar system? The answer lies in Jupiter. From the very beginning, Jupiter's gravity acted like a cosmic sculptor, reshaping the asteroid belt into what we see today. With its colossal mass, Jupiter pulled relentlessly on the fragments drifting between Mars and itself. Every time rocky and icy bodies tried to merge into a larger planet, Jupiter's influence tore them apart, scattering them into new orbits. Instead of one dominant world forming in the belt, the region became a graveyard of fragments, leftovers from creation that never had the chance to grow. This constant tugging created Kirkwood gaps, vast empty lanes carved into the asteroid belt. These gaps weren't random. They were the result of Jupiter's rhythmic gravitational pull. Any object unlucky enough to drift into these unstable zones was nudged away, forced into new paths that carried it far from its neighbors. Over millions of years, the belt became a patchwork of emptiness and clusters, shaped entirely by Jupiter's invisible hand. And yet, in this turbulent environment, Ceres endured. While countless planetesimals were shattered, consumed, or ejected, Ceres managed to hold itself together. Its roundness, achieved through hydrostatic equilibrium, gave it stability. Its mixture of rock and ice made it resilient. Against the backdrop of Jupiter's chaos, Ceres became the quiet queen of the belt, not by dominating, but by surviving. But survival came at a cost. Ceres could never grow into a full planet. Jupiter's gravity kept the region unstable, preventing any single body from gathering enough mass to clear its orbit. Instead, Ceres remained small, trapped in a delicate balance. It became something in between, too large to be just another asteroid, too small to be a planet. A dwarf planet defined as much by its environment as by its own internal physics. This makes Ceres unique. It's not just a relic of the asteroid belt. It's a reminder of what might have been. Had Jupiter not interfered, the belt could have birthed a planet rivaling Earth or Mars. Instead, it became a realm of fragments, with Ceres standing as the largest survivor. But Jupiter's influence didn't just shape the belt. It left scars deep inside Ceres itself, scars that scientists are only beginning to uncover. For a world that looks so quiet from the outside, Ceres hides an interior far more complex than anyone expected. When NASA's Dawn spacecraft orbited Ceres, it wasn't just snapping pictures of craters and plains. It was measuring gravity, mapping density, and listening for subtle clues about what lay beneath the surface. What scientists uncovered was astonishing. Ceres isn't a uniform block of rock and ice. It's layered, structured, and alive with hidden processes. This layered structure tells a profound story. Ceres isn't just a frozen relic. It's a differentiated world, shaped by gravity, heat, and water. It may not have continents or oceans, but it has architecture, crust, brine, mantle, and core, all whispering of a past far more dynamic than its calm exterior suggests. And here's the most controversial idea. If brine pockets still exist today, they could provide tiny habitats for microbial life, not bustling ecosystems, but microscopic survivors clinging to saltwater veins in the dark. If proven, it would mean that even the smallest worlds can preserve the chemistry of life across billions of years. But whether life exists or not, one thing is certain. The secrets inside Ceres are far from ordinary. For every discovery about Ceres, there's an equally powerful debate. And the biggest question of all is this: could this quiet dwarf planet still be alive in some way today? Scientists are divided. On one side, researchers argue that the faint warmth left inside Ceres, the slow decay of radioactive elements buried deep in its mantle, may be enough to keep tiny pockets of brine liquid even now. If true, that means Ceres isn't just a fossil of ancient habitability. It's a world with ongoing chemistry, quietly shifting beneath its crust. Others push back, saying the evidence is too thin. They argue that Ceres is simply too small, too cold, and too old to sustain liquid water today. To them, the bright salt deposits are relics of ancient activity, not signs of something happening now. In their view, Ceres is a museum piece, fascinating but frozen. But here's where the controversy gets even more intriguing. If brine pockets do exist, they could provide tiny habitats for microbial life. Not sprawling oceans, but microscopic survivors clinging to saltwater veins in the dark. Some scientists believe this possibility is worth serious consideration. After all, life on Earth has been found in extreme environments. Deep underground, inside rocks, even in acidic pools. If microbes can survive here, why not in the hidden brines of Ceres? This debate has fueled speculation far beyond the scientific community. Could Ceres be one of the most overlooked candidates for extraterrestrial life in our solar system? Could its quiet surface be hiding activity that challenges everything we thought we knew about small worlds? The controversy isn't just about science, it's about imagination. If Ceres is active, it forces us to rethink the boundaries of habitability. If it's frozen, it still preserves chemistry from the earliest days of the solar system, making it a priceless time capsule. Either way, Ceres refuses to be ordinary. But whether Ceres is alive or fossilized, one thing is certain: its story isn't finished yet. After all the discoveries, debates, and mysteries, one truth about Ceres stands out. Small worlds can hold enormous secrets. Ceres is not a giant like Jupiter, nor a glowing beacon like Venus. It doesn't command moons or shine brightly in the night sky. Yet, in its quiet orbit between Mars and Jupiter, it carries a story that could reshape our understanding of the solar system. From organic molecules to shimmering salt deposits, from whispers of ancient oceans to the shocking possibility of migration, Ceres proves that even the most modest worlds can be extraordinary. Its roundness, achieved through hydrostatic equilibrium, is more than just a shape. It's a symbol of patience, gravity slowly sculpting a jagged fragment into balance. Its chemistry, rich in ammonia and salts, is more than just minerals. It's evidence of a journey across billions of kilometers, a traveler carrying the fingerprints of distant regions. And its brine pockets, whether ancient or still active today, are more than just water. They are potential habitats, tiny laboratories where the chemistry of life may have stirred in silence. Ceres bridges categories. It is planetary in its structure, asteroidal in its environment, and migratory in its origins. It is a survivor of Jupiter's chaos, a messenger from the outer solar system, and a time capsule of creation. In its calm, patient orbit, it reminds us that the universe is not built only by giants and violence, but also by persistence, subtlety, and quiet endurance. So the next time you look up at the night sky, remember this. Somewhere in the darkness, a small dwarf planet drifts quietly, carrying secrets older than Earth itself. Secrets of ice, rock, and chemistry. Secrets of survival against impossible odds. Secrets that may one day reveal how life began. If a world as small and quiet as Ceres can rewrite our understanding of the solar system, imagine what else is waiting in the dark, silently holding the answers we've yet to ask.